All right, this video is the last video that I'm going to be making for Chapter 3 of Pre-Calc 11. It is the second half of a lesson covering the tail end of Section 3.3, which is the completing the square section. So the first half of this video covered optimization and focusing specifically on some area and some fencing related stuff. The second one is also going to be focusing on optimization, but looking at it from a more business point of view. If you haven't seen the previous video or you don't know how to complete the square, you are in the wrong place. So go back to one of the previous videos till you find the one that you're looking for. All right, so here is our setup. We've got a business owner who is looking to maximize revenue in her job, and she wants to know what price she should be selling some products at. She's also got some information that she's picked up somewhere. So she knows that when she sells her items for $60 a piece, she's going to be selling 100 units per week. So that's sort of our baseline, $60, 100 units. She's also noticed from maybe some experience over time that if she lowers the price by $2, she's going to sell around 5 more units. And so every time she makes that change, she'll sell 5 extra. Her question, and what we're going to be investigating, is how much should she charge so that she can make the most money possible, or get the biggest revenue possible at least. It's a delicate balancing act, because if you charge too much, you won't sell enough items. But if you don't charge enough, even though you sell a lot, you're not going to make much money. So we've got to find the sweet spot. So this is another optimization question, and once again, we're looking to maximize our revenue. If you think about that and you think of it in terms of quadratics, that means once again we're going to be looking for a vertex. And that means we can probably imagine that we're going to be dealing with some kind of parabola or some kind of function that looks kind of like this, except we're not going to be graphing it. Before we can manage this question, there is one really important piece of information that's good to know. Revenue, which just means how much money a business makes, can be calculated as the number of units that you sell. So however many things you sell, times however much money you're charging. Which, if you think about it, makes logical sense, right? If you sell 10 things to your friends for $5 a piece, well, you've sold $50 worth of stuff. So we're working in the same place here, just with, a slightly more complex situation. Let's start by defining a really important variable. And this is something you're going to do for any question like this that you run into. The situation might change, but the idea is going to be the same. So we're going to say n is going to be the number of $2 changes to the price. Or, well, $2 decreases to the price, I guess. All right, so we know every time we drop $2, that affects how many people we get. So we're going to use that variable to kind of construct our equations here. Our price then, if we stop and think about it, is not too hard to figure out. Remember, we started with a baseline of $60. Right, so $60, and then every time we changed our price by $2, something happened. So $60, and then we're going to take away $2 some unknown number of times. So n, again, is just however many times we're making that change. Our units sold works in pretty similar logic. So if you'd like to try to figure it out for yourself, pause the video now, give it a shot for 30 seconds. If you find it out, great. If not, come back and we'll see how we can do it. The same thought process should apply, so give it a try. All right, so going back up to the question again, we can see once again that we're selling 100 units as sort of our baseline. And then every time we make that $2 change, we're going to sell 5 more units. So we're working with our baseline again. This time it's 100. But now our change is positive 5. We're adding 5 over and over again. So we can take these two things, our price and our units sold, and we can basically just put them into this revenue formula that I gave you up here. So we're going to replace price and units sold with these two binomials. If we do that, we end up with R instead of revenue equals 100 plus 5n times 60 minus 2n. And then if we stop and look at that, that looks like something we can work with. That's actually going to be quadratic. But now we've got to make something out of it. So our first step with this particular function is going to be to FOIL it to get it into a form that we can work with. So if you don't remember what FOIL stands for, that is first, outside, inside, and last. So we're going to multiply our first two terms, the 160, our two terms on the outside, our two terms on the inside, and then the last term in each set of terms. So 100 times 60 gets me 6,000. 100 times negative 2 is negative 200n. 5n times 60 is 300n. And then 5n times negative 2n is negative 10n squared. So if we flip things around and simplify this, we end up with negative 10n squared plus 100n, and then plus 6,000. And that is just a really standard looking standard form equation. So once again, we're trying to maximize this, which means we need to complete the square. Because we need to know where that vertex is. So going through that real quick, we take out the a value. We divide by 2 and square. And add and subtract. It's going to get me 25. We move out the negative term. And multiply it by a, which in this case is going to be negative 25 times negative 10 for 250. And then we simplify stuff and we factor and we see where we end up. So our final equation is r equals negative 10 times n minus 5 squared plus 6,250. So this is the equation that's going to tell us everything we need. So once again, don't jump into conclusions as far as what this equation is telling you. You don't want to just say, oh, okay, this is my vertex, I'm done. So our vertex is at 5, 6,250. But we got to think about what those things mean. So just like in the fence questions where we were finding length or width and then area, here, 6,250, that is our maximum revenue. That's R, right? It's a Y value, but we don't have Y. But we don't really care about the revenue as far as answering the questions go. What we care about is the price. But 5 isn't the price. 5 is N, which, if you remember, is how many price changes you're making. So that's what we need to work with. N equals 5. Our price, which we found out earlier, was 60 minus 2 times 5. Or 2 times n, rather. So we're going to take the n, we're going to replace it with a 5, and we're going to figure out what the best possible price is for us to be able to make the most money. So that's going to be 60 minus 10, which is just going to be $50. The question didn't ask us for how many units we're going to sell, but sometimes they might, so let's figure that out too while we're at it. Remember, our sales was starting at a baseline of 100 and then adding 5 each time. So that's going to be 100 plus 5 times 5, which is going to be 125. So there we go. Our best possible price is going to be $50, which is going to get us 125 sales. Anything more than that or less than that, we'll be making less money. And so that is your second kind of optimization question. If you've managed all of this and everything makes sense, you are now ready to move on to chapter 4, which will be about quadratic equations and solving equations using a few different strategies, some that you know and some that you don't. So once you're ready, move on to that and see what you get.